Look down any city avenue, and you will see a world built on concrete. It is the absolute foundation of modern infrastructure. This chart shows global material consumption. Concrete dwarfs all other materials we produce. Humanity uses 4.2 trillion kilograms of it every single year, second only to water. Despite relying on it for nearly everything we build, the recipe we use to make it is ancient. We still mix, pour, and lay wet cement, much the same way we have for decades. Depending on this antiquated process to build tomorrow's cities creates a massive, unavoidable bottleneck for our climate goals. The problem begins at the very start of the supply chain. Making traditional cement requires carving massive, multi-tiered quarries into the earth to extract raw limestone. That limestone is crushed and fed into enormous rotary kilns, where it has to be baked at extreme temperatures, exceeding 1,500 degrees Celsius. Hitting and maintaining those temperatures requires the continuous, heavy combustion of fossil fuels. This chart visualizes global CO2 output. Traditional cement production alone is responsible for a staggering 8% of the worldwide total. As the global population expands and demands more housing and infrastructure, continuing to bake our building materials guarantees we will overheat the planet. Researchers and engineers are developing an alternative. Instead of baking cement with heavy industrial heat, we can grow it using living biology. The new recipe completely removes the industrial clinker. It requires only simple sand or gravel, water, calcium lactate nutrients, and specialized bacteria. Because this relies on living organisms, it requires absolutely zero heat. The entire reaction happens at ambient room temperature, looking more like a quiet hydroponic farm than a loud, heavy industrial factory. The core mechanism is a process called microbially induced carbonate precipitation. The bacteria feed on the calcium nutrients and excrete a hard, crystalline barrier around the sand particles, cementing them together. This biological glue is entirely natural. It is the exact same calcium carbonate that gives seashells and coral skeletons their structural strength. By cloning nature's own biomineralization process, we can transition construction from a high-energy extractive industry into a low-energy biological one. This chart compares the carbon footprints of production. By eliminating the industrial kiln, the cradle-to-gate carbon emissions for biocement drop by more than 90% compared to traditional methods. If we use a specific variant of microbes, photosynthetic cyanobacteria, that carbon footprint goes negative. Because these bacteria use photosynthesis, they actively pull existing carbon dioxide directly out of the atmosphere to fuel their growth. This completely flips the math of urban development. Instead of our city skylines acting as the world's largest carbon emitters, they can become active carbon sinks. This biological process is already moving out of the lab and into commercial manufacturing. Companies are growing standard masonry bricks, interlocking blocks, and complex structural trusses. Compare the clean, ambient production of biocement to a traditional brickyard, where massive exhaust towers continuously vent smoke to dry out clay blocks. Developers do not have to choose between structural integrity and climate responsibility. These grown materials match the compressive strength of their traditional baked counterparts. Because the material is biologically forged, it retains a unique property long after the blocks hardened. The bacteria do not die during production. They enter a dormant hibernation state, capable of surviving deep inside the concrete matrix for up to 200 years. When the concrete inevitably cracks and water seeps into those fissures, the dormant bacteria wake up. The awakened microbes feed on the calcium lactate and secrete fresh calcium carbonate. This new growth blooms across the gap, permanently sealing the crack. By shifting our industrial model from extracting and baking to cultivating and growing, the construction industry can transition from being one of the world's heaviest polluters to a vital tool in combating global warming.